Imagine gliding across the countryside at speeds so fast you could finish your morning coffee in one city and your breakfast in another. With a quiet whoosh, the scenery outside transforms into a blur, and before you know it, you're hundreds of miles from where you started. But how do bullet trains maintain such speed while preserving comfort and safety? Today, we unravel the secrets behind the making of bullet trains, revealing the engineering breakthroughs that defy time and distance. The spark of innovation. Bullet trains didn't just appear overnight. They emerged from the relentless pursuit of faster, more efficient travel. Engineers in Japan faced a growing population and limited real estate, prompting a radical solution. They wanted a train that could move large numbers of people at incredible speeds without sacrificing comfort. Initial prototypes were tested on shorter tracks to gauge aerodynamic limits. Since friction multiplies with speed, the challenge was finding materials and designs to handle the stress. Everything from the nose shape to the steel composition had to be rethought. Engineers borrowed aerodynamic principles from aircraft design, hoping to reduce drag and conserve energy. Over time, these concepts evolved into the high-speed trains we know today. Manufacturers found that the nose cone significantly affected speed and stability. Each iteration was tested in wind tunnels to cut air resistance, reduce noise, and boost efficiency. In some cases, a few centimeters made all the difference at over 300 kilometers per hour. Early models faced challenges with pressure changes when entering tunnels, which could cause loud sonic booms. Engineers tackled this by refining the nose shape and adding venting systems to stabilize air pressure. These modifications greatly improved passenger comfort and neighborhood noise levels. Developers also explored advanced braking and multi-motor configurations, so one glitch wouldn't halt the entire train. This multi-decade process of trial, error, and breakthroughs turned bullet trains into symbols of cutting-edge engineering. Every improvement was data-driven, from passenger comfort surveys to stress tests on rail metals. The end result? A fusion of mechanics, electronics, and design built for speed, reliability, and safety. Now, let's delve into the steps that bring these steel giants to life. Designing the streamlined exterior. Let's start with the frame known as the car body. Manufacturers use lightweight materials like aluminum alloys to keep mass manageable. This shell must be strong and flexible, built to endure aerodynamic forces. Robotic welding systems connect panels with minimal seams, reducing drag. Then comes the nose, shaped by extensive wind tunnel testing. Elongated fronts push air aside gently, lowering shock waves in tunnels. Designers also account for crosswinds to keep the train stable in storms. On top, the pantograph draws power from overhead lines with minimal sparking. Below, the bogies, or wheel assemblies, attach to the car body with dampers to absorb shocks. In many bullet trains, bogies are shared between two cars for weight reduction. Each wheel is precision crafted to reduce friction and wear. Even color and finish matter. A glossy coat can shave off air resistance. Full-scale prototypes run on test tracks at speeds above the normal limit. Any anomalies revealed by sensors lead to design tweaks for improved aerodynamics. This synergy among shape, materials, and systems ensures a sleek, efficient exterior. Engineers fine-tune the aerodynamic profile by adjusting angles around windows and doors, ensuring minimal turbulence. Some models feature specialized side skirts that cover the gap between the train and the rails, further reducing drag. Air intakes and vents are strategically placed to cool components without creating unwanted airflow disruptions. Each of these design choices contributes to smoother acceleration, lower energy use, and a quieter ride. Wondering if these changes actually matter? At 300 kilometers per hour, a small design tweak can save megawatts of power each year, leading to significant operational cost savings and environmental benefits. Power and propulsion. Unlike traditional trains that rely on a single locomotive, many bullet trains use distributed power systems. Multiple cars have their own electric motors, improving acceleration and traction. Power comes from overhead lines, traveling through the pantograph and into onboard transformers. Motors convert electrical energy into mechanical force, spinning the wheels at tremendous speed. In some models, regenerative braking feeds energy back into the grid. That humming sound is the inverter, turning direct current into alternating current. The control system adjusts speed, torque, and traction in real time to handle varying conditions. Distributed propulsion also helps distribute weight, reducing track stress. Cooling fans and radiators prevent overheating, especially in tunnels where air circulation is limited. All these factors create a robust propulsion system that keeps bullet trains racing along. Engineers program the train's onboard computer to detect wheel slip and instantly modulate power output. This quick response stabilizes the ride during rain or snow. High-power semiconductors in the inverter systems reduce energy loss and optimize performance. Safety protocols ensure no single motor failure can compromise overall operation. In fact, many bullet trains can run efficiently even if one motor car experiences issues. On downhill stretches, dynamic braking systems help control speed without overheating friction brakes. After assembly, a comprehensive test run identifies any hiccups in the propulsion chain. Data analysts parse gigabytes of sensor readings, looking for hotspots or unusual vibrations. Adjustments follow, ensuring the final product meets strict benchmarks for speed and safety. Ultimately, bullet train propulsion is a marvel of electrical and mechanical engineering, enabling journeys once deemed impossible. Everything is calibrated with care. Now that we see how they achieve speed, what keeps them safe at such breakneck paces? Safety systems. Speed is thrilling, but safety is mandatory. Modern bullet trains employ automatic train control to monitor speed, braking automatically if limits are exceeded. Digital signals update train positions and track conditions in real time. Earthquake detection systems can halt operations the instant seismic activity is identified. Reinforced tracks and overhead wires further reduce the risk of damage. Doors remain locked until platforms are properly aligned. Pressurized cabins minimize ear discomfort in tunnels. Fireproof materials and extinguishing systems help contain any blaze. Emergency lighting and communications stay active even if main power fails. Regular drills prepare staff for unlikely emergencies. Windows use laminated glass that resists shattering at high speeds. Fenced corridors and object detection systems address debris or animals on the track. Maintenance teams employ ultrasound to find cracks before they cause accidents. Predictive analytics schedules repairs ahead of time. Through layered technology and careful planning, bullet trains uphold an extraordinary safety record. Collision avoidance relies on spacing trains so they never risk rear-ending one another. If a train slows unexpectedly, trailing units receive instant alerts to adjust their speed. Data from sensors runs through centralized control rooms, where operators can initiate rapid interventions. Every door, brake, and sensor is tested to strict standards before service begins. In snow-prone areas, anti-icing equipment prevents buildup on tracks and overhead lines. Infrared detectors can spot overheated bearings or brakes, triggering immediate maintenance checks. Evacuation protocols ensure passengers can be guided to safety if needed. These systems work in harmony to address human error, mechanical glitches, and natural disasters. While incidents are rare, contingency plans exist for everything from signal loss to extreme weather. Engineers favor strong, lightweight materials. Still curious about passenger comfort, interiors, and passenger experience? Stepping inside a bullet train feels futuristic, with wide seats, ample legroom, and large windows. Materials are chosen for comfort, durability, and reduced noise. Soundproofing is key, given how fast the train travels. Walls and ceilings often contained layered insulation to dampen external noise and minimize vibration. Some trains offer reclining seats with power outlets and tray tables to accommodate work or leisure. Cabin pressure control helps reduce ear popping when passing through tunnels at high speed. Lighting is carefully designed to be bright yet soothing. In premium classes, you might find footrests, extra seat width, and even reading lamps. Passenger information displays keep everyone updated on arrival times, speeds, and station announcements. Some operators provide Wi-Fi and entertainment screens, turning long journeys into productive or relaxing sessions. Temperature control systems adjust to shifting weather, maintaining a comfortable environment year-round. In certain models, air filtration systems keep the cabin fresh, which is particularly useful in congested regions. Restrooms are designed to be spacious enough for travelers with luggage, and some are wheelchair accessible. Window curtains or blinds let passengers control their level of light exposure. The color scheme generally favors neutral, calming tones to reduce travel fatigue. Luggage racks near entrances or above seats keep bags secure without blocking walkways. In addition to cleanliness, staff often walk through the train to assist with questions or problems. Of course, the smooth ride is part of the allure. Advanced suspension systems absorb rail imperfections, so you barely feel the bumps. Are these features overkill for a quick trip? Operators believe a pleasant ambiance attracts more riders, boosting revenue and justifying the added investment. It's all about merging cutting-edge tech with human comfort. Seriously. Now that you understand how bullet trains combine cutting-edge design, power, and safety, you'll want to explore our video on how submarines are made. Click here to see the secrets of underwater warfare. Thank you for watching. See you next video.